Bismillahirrahmanirrahim. Assalamualaikum and a very good evening to our lecturer. So today, our group will present about group project 2, which is object detection and a custom data set. Okay, next. Okay, for the introduction, the YOLO V5 model is a powerful object detection architecture that has gained popularity due to its lightweight, fast, and accurate performance. So basically, in this project, we will explore the process of retraining a YOLO V5 model with a custom dataset, allowing it to detect different classes of objects defined by the user. Okay, next. Okay. So for the concept, the our project is we will run the a pre-trained YOLO V5 model to perform inference on image, webcam stills, and videos. So this is will provide a baseline understanding of the model capabilities and performance. So then we will see the result from the YOLO V5. So that this will involve the fine-tuning the model on the custom dataset to detect the newly defined classes of object. So next, we will go to our project. Oh, yo, for the overview, okay. Just basically with our project, we will adjust the training parameters based on the model performance on the training and validation data, aiming to optimize its accuracy and generalization. By the end of the project, we expect to have gained hands-on experience in retraining the YOLO V5 model, achieve improved detection of specific class of object, and acquired a deeper understanding of the training validation and testing processes involved in object detection model. Okay, next we will go to our uh, project.
All right. The so we will continue for our first task. We will build and annotate a new data set. So the first thing we create our group account at RoboFlow, and then the second thing we invite the one that in charge in the programming task, and after that we after complete the annotation of the feature, we will generate the coding and export it. Next, we will generate the coding and export it, and you will provide our code. Then we copy the code to the Google Colab. Next, so the first after that we will continue we run the code and then we will get the result. So the first thing we will talk about our result is graph confusion metric. As you can see, this TP1, TP2, TP3, that is a two positive. Two positive means that it correctly classify for each class, which is for glasses and calculator. And FP is false positive. FP means that it detect the incorrect classifier as that class, like FP1, FP12, FP13, and FP23. And the last one is FN, false negative. False negative, which is uh, an actual class that were incorrect classified as another class, which mean it's detect another class, but the one that we want is different to the result. So analyzing the distribution of this value uncover the model strength and weakness by reviewing the specific class name and key metrics such as accuracy, precision, and recall. We can identify which class the model predict well and which is struggle with, providing a foundation for further model improvement and fine tuning. Next, the second one is a graph 2 is show the precision confidence curve. So as you can see, we got two class, uh, calculator and glasses. The blue one is all class accuracy, confidence level. So initially, the curve show high precision because the model only detect object it is very confident about, such as glass and glass calculator. This curve help identify the optimal confidence threshold where the model effectively balance detecting most actual object while minimizing false positive. And analyzing the curve shape and steepness provide valuable insight into the model behavior, enable parameter tuning or confidence threshold, adjustment for optimal performance in specific application. This is for the
So for graph 3, this is for the F1 confidence curve, which this graph shows the trade-off between precision and recall for our YOLO V5 model at different confidence thresholds. It is such as a performance landscape across varying levels of certainty the model has in its predictions. So as you can see, for the thin blue line, which is for the calculator, and the orange line is for the glasses. So lowering the confidence threshold might detect more objects, but includes more incorrect detections. But raising the threshold makes it more accurate, but might miss some true positives. So for the fourth graph, this is the precision recall curve. So this curve shows the trade-off between precision and recall for a classification model. The curve traces the model's performance as the transition threshold shifts, revealing its ability to correctly identify true positives while minimizing false positives, which a perfect AI model would hug to the top right corner, which you can see in our graph here, which signifies high precision even at high recall. In the graph, the calculator, which is at a score of 0.995, and glasses at a 0.995 also, is approaching to 1, which means the model is at high precision.
Okay, thank you, Mio. So for the recall confidence curve, it give insight for the trade-off between recall and the confidence. At high recall and low confidence, we can see it hovers around the value 1, while the confidence increase at the lower recall, it reach the near 0. So that's mean the performance of the model involving high confidence uh, might create a false positive. Okay, next. For the graph 6, correlogram, it helps us to view the correlation between different parameters, where we can see there's a lot of square tile, which can indicate the correlation between a certain parameter, where the darker color shows strong correlation, while the lighter color show weak correlation. Okay, next. So this is one of our tests for using our model on the webcam image. As you can see, the confidence level for the glasses and the calculator is about 0.62 and 0.71 respectively. So why does we cannot get one confidence level? This is because of multiple factor, which for example, the camera quality might affect how the the model can predict the image, and also the background can also affect the detection process. However, it can still detect both of the class when we take the picture.
Hello, my name is Mio, and now I'm going to talk about the collab codes. So from here, we go to 2.1, which is the install requirements. We run this code once only for each session. Next, we get this code from the RoboFlow website for our dataset, and then we paste it here and then run this. After we run this, we run this one, which as you can see, the output here shows our classes for our dataset, which is calculator and the glasses. Next, we run these codes here. After that, we go to the application of the transfer learning to YOLO V5. In here, we we define the epochs to be 100 so that it can actually so that the model actually can detect our objects easily. So here you can see it ran for about 3 minutes and 84 seconds. So next, we evaluate the custom YOLO V5 detector performance using TensorBoard. So in here, as you can see, all the curves are present, which correspond with each other. As you can see, the configure matrix, the R curve, and the P curve, and the PR curve, F1 curve. So all of it is in there. After that, we go to display the training output graphs, as you can see. Uh, as you can see, the output graphs are here, uh, easily readable for easy observation. Next, we go to we run the inference with the training weights on the test images. So we run this, and then we run this for the test images here. As you can see, the model depicts the objects accurately. Next, we use the custom train model on the webcam. So here we run this, and we run the helper functions here. So after that, we go to the webcam images. So as you can see, with this image, that's me holding a calculator, and I wear glasses here. The model actually recognizes that I am holding a calculator and wearing some glasses, and depicts that it is 68% and 88% positive that those are the images from our data set, or images that they think that it is from the data set. So next, we go to the webcam video. So in here, this is a live demo. So as you can see here, it's loading. So that, let me, all right. So there the model actually recognizes me. I'm wearing some glasses now for the calculator here. So there it is. It actually recognizes the calculator. All right, thank you.
Today, I would like to present about lesson learned for this project. First of all, is customization necessary, which we can see returning YOLO V5 on a custom dataset that tailors the model for specific application covered by the COCO dataset, enhancing relevance and accuracy. The second part is we learn to how dataset prepared, and this can be described as class selection, which is can choose non-COCO classes to focus on unique objects. Image collection also can be gathered at least 20 diverse images per class via web scraping, screenshot, or personal photos. And when we go to annotation, it uses tools like RoboFlow for consistent bounding box annotations. And the third one is tools utilization. We can see that RoboFlow it facilitates datasets management and annotation. And the last part is challenge and solution, which is for the first point is data diversity. That we need to ensure a varied dataset for robust model training. And the last one is computational resources, which can be ensure also access to sufficient computational power for smooth training.
Okay, so for the critical reflection, throughout the project, we encountered several challenges and learned valuable lessons, such as, okay, next, first is improved planning and organization will have help in gathering a diverse and sufficient amount of image for the custom dataset. Second is further development of annotation skills will have ensure more accurate labeling of image with bounding boxes. Fine-tuning the YOLO V5 model on the custom dataset proved challenging, specifically in adjusting training parameters to optimize performance. Next is time constraints impact the depth of exploration and experimentation with different techniques and approach. Next, valuable insights were gained in running the pre-trained YOLO V5 model for inference and utilizing Python, PyTorch, Google Colab, and Python for training and evaluation. And lastly is lessons learned from this project will be applied to enhance skills and approach in future projects involving object detection models.
For a conclusion, here we can be conclude that returning the YOLO's model on custom dataset significantly improve its performance for specific data. Running the pre-trained model highlighted its capabilities. It's also building and annotating a dataset for new non-socio class extended the model's utility. And the last part that we can conclude is tools like RoboFlow ensure efficient data management and precise annotations, addressing challenges like data diversity and accuracy. This initial testing and in iterative refinements refinements show substantial performance gains, emphasizing the importance of customization. This project provides a clear understanding of retaining result, resulting in a tailored model for specific object detection needs. Okay, that's all from me. Thank you.